Alright, number 3. To divide polynomials, we have a method called synthetic division. Now, since this polynomial x cubed minus 8 is being divided by the binomial x minus 2, our factor is x minus 2. So what goes in the box? Positive 2. What numbers do you bring down from the polynomial? 1, 0, 0, negative 8. Because think about it, aren't you missing the x squared term and the x to the first term? So you have to have 2 zeros for your x squared and your x. Now we bring down the 1, it then multiplies by the 2 to make a 2. When you combine those, it makes a 2. Then you multiply it by the 2 to get a 4. When you combine those, you get a 4. It then multiplies by the 2 to make an 8. And when you combine those, you get 0, and that is your remainder. So, since our answer started out since our question started out x cubed, our answer starts out with x squared. The 1 belongs to it, not that you have to write it, and then plus 2x plus 4. Alright, number 4. We're dividing those two polynomials, so what number do we put in the box? 5. Positive 5, and then what numbers come down? Okay, what do we then do first? Bring down the 1. Anything that drops below the line, what do we do with it? Right, multiply it by the box number. 1 times 5 is 5. Negative 8 plus 5 is negative 3, though. And then we multiply it by the box number, and that gives us a negative 15. And when we combine those, we get a positive 2, and we multiply that by the box number, we get a, right? And so what does your answer look like? Correct. Okay, go ahead and flip to the next page. Okay, I want you to try 5 and 6 by yourself, and after we go over those, we are moving on to the new material. Okay, so try 5 and 6. Okay, number 5, what number goes in the box? What numbers come down? Right, you have to be careful and look for skipped terms because you have to fill those with zeros. Shh. We then bring down the 1, it multiplies by negative 4. 0 minus 4 is negative 4. You then multiply it by negative 4 to get a positive 16. When you combine those, what do you get? Negative 12. And then when you multiply it by negative 4, you get a positive 48, which gives you a remainder of, okay? So, what is the answer? Alright, number 6. What number goes in the box? 4. Positive 4. What numbers come down? Okay, it did not skip a term, so we didn't have to worry about filling a spot with a 0. The 1 comes down, multiplies by the 4. Negative 12 plus 4 is negative 8. It then multiplies by the 4 to make a negative 32. That becomes a 12, which multiplies by 4 to make a positive 48, and that gives you a remainder of 0. So what is your answer? Right. Okay, so you need to definitely know how to do synthetic division to be able to do the topic we're about to learn. Go ahead and turn to the next page. We're not going to finish out the rest of those on that page, but if you feel like you need more practice at synthetic, there's you a few more practice problems. Okay, here we go. You better be paying attention. Let's look at the equation x cubed minus 5x squared plus 9x minus 45 equals 0. Okay, so what I'm going to do is I'm going to graph it. So y equals x cubed minus 5x squared plus 9x minus 45. Okay, all I've done so far is I typed in this polynomial's equation. before I actually hit graph to see the picture of it, what degree is it? 3. How do you know that? Because its highest exponent is a 3, right? Now, degree 3 polynomials have how many zeros? How many? 3. That's why they're degree 3, because they have 3 zeros, which means they either cross through or bounce or flatten out, totaling up to 3, correct? Well, we're expecting 3 zeros, but when we graph it, we only see 1. And where does that 1 0 occur? Positive 5. Okay, and see, that's a picture over here of that positive 5. So what this means is the other two solutions that we were expecting to see are imaginary. And today we are going to learn how to find the two imaginary solutions. Okay, so is everybody still with me? Everybody understands that the first thing we've got to do to solve this is graph it and find its real zero, which was at positive 5. Now we're going to use that real zero to find the two imaginary solutions, the ones we didn't see that we were expecting. This is where synthetic division comes in. That 5 is going to be used as your box number. Okay, from the polynomials function, what numbers do we bring down? Right? So the 1 will drop. It will multiply by 5 and become 5. That will become 0. It will multiply by 5 and become 0. And then that will become 9, which will multiply by 5 to become 45. So the remainder of 0. Now, remember how since the question started out x cubed, we start our answer out as x squared? So isn't this like 1x squared plus 0x plus 9? But the 1 is not necessary to write, and neither is the 0x. So aren't we just technically left with x squared plus 9? Okay, so far this is what we've done. We graphed it. We were expecting to see 3 zeros because it's degree 3. But we only saw 1. That means this graph only has one real solution, and we're going to find that, or we're going to use that one real solution of 5 with synthetic division to find the other two. Okay, so here we go. Anytime you're just left with something like this, what's the easiest way to get the x by itself? Subtract the 9. And so x squared will equal what? But negative 9. Then to get x by itself, what do we do? Square root both sides. And so x equals, what is the square root of 9? But since it's negative, I, and remember how anytime we solved these when we were learning them, we always put plus or minus? So our three solutions are 5, the real one that we found on the graph, positive 3i, and negative 3i. That's why we couldn't see 2 of the 3 because they're imaginary. That our three solutions we just found were 5, 3i, and negative 3i. Okay, the original polynomial was x cubed minus 5x squared plus 9x minus 45. So I'm going to type in that polynomial, except for every time I have an x, I'm going to type in my first solution, which was 5. So 5 cubed minus 5x squared plus 9x minus 45. So see how I just retyped in that original polynomial that we graphed? X cubed minus 5x squared plus 9x minus 45. But what did I put in the x place of all of them? 5. That's because I want to check to make sure this is indeed one of the solutions. When I hit enter, I get 0, which lets you know, since it was set equal to 0, that that is one of the 3 solutions. Now let's check our imaginary. So 3, but to get that I that's in blue, you have to hit second. And then cube it. And then minus 5 x, which I'm putting in a 3i for, squared, plus 9 times x, which is 9 times 3i, minus 45. Okay, so now I'm checking to see if this is my second solution. It gives me 0, so it is. Now I'm going to check to make sure negative 3i is indeed my third solution. So instead of retyping all of this in though, I'm just going to go up and copy and paste it. And then I'm just going to go back to each 3. And I need it to be negative 3, so if you hit second, insert, negative, it'll put a negative in front. And then you don't have to type it all back in. So second, insert, negative. Oops, I put it in the wrong place. Let me fix that. So see now how every time in the x place I now have a negative 3i? And I get 0. So that confirms that I did it right. These are the 3 solutions. And remember, the reason we were looking for 3 is because this was a degree 3 polynomial. Alright, now, I want to point out that the only reason we were able to solve this one the way we were is because all I had was an x squared and a constant. The middle term was no longer there because it was 0. You're not going to be able to solve all of these with that easy method because not all of them are going to cancel out in the middle. Okay, so let's look at the next one. They want us to first graph this polynomial, x cubed minus 8. Since it's x cubed minus 8, what degree is it? 3. So we're expecting 3 zeros, right? But when we graph it, we only see 1. We were expecting 3 though, so the other 2 must be imaginary. Where is the one real solution? 2. Okay, so I already know one of my answers is 2. I'm going to use that one real solution in synthetic division to find the other 2. What numbers do I bring down from the original polynomial? Right. So I bring down the 1. It multiplies by the box number 2 to make a 2. When those combine, you get a 2. It then multiplies by the box number to make a 4. 0 plus 4 is 4. 4 times 2 is 8. And that's the remainder of 8. So see, this time when you write your answer, it's 1x squared plus 2x plus 4. The middle didn't cancel out, so you can't use this same square root method we just did. You're going to have to use the quadratic formula. Okay, so back when I taught you the quadratic formula, the first thing I taught you is you have to identify the a, b, and c. What number is in the a place? What number is in the b place? 2. Because remember, it's in that form ax squared plus bx plus c. And so what is your c value? Now you just plug it into this formula. So x equals negative b, which would be negative 2, plus or minus the square root of b squared, which would be 2 squared, minus 4 times a times c, all over 2 times a, which would be 2 times 1. Okay, so far all I've done once I got my answers from synthetic division is I identified the a, b, and c of it, and I plugged them in to where they go into the quadratic formula. Now I'm going to start simplifying this. X equals negative 2 plus or minus the square root of what? What is 2 squared minus 4 times 1 times 4? Negative 12. And then all over 2, because 2 times 1 is just 2. Okay, now just watch for a second. This can be reduced by factor tree. 4 times 3, 2 times 2 times 3. So circle, kill 1, kick 1 out, and 3 goes back inside. So instead of negative 2 plus or minus the square root of negative 12, it's now negative 2 plus or minus 2i root 3. And then at this point, what I would do for simplifying purposes is I would break this 2 and put it under both. because then you'll see that that becomes a negative 1, and this becomes a 1i square root 3. So those are your other two solutions. Okay, so your second solution is negative 1 plus I root 3, and your third solution is negative 1 minus I root 3. Okay, now you can even type these in. Okay, so if I go back to the original polynomial, x cubed minus 8, okay, so x cubed minus 8. Well, my first x is 2, so 2 cubed minus 8. Doesn't that say x cubed minus 8? I just replaced the x with a 2, and I got 0. So that confirms that that is indeed one of the three solutions. Now for the next one, in the x place for the next one, I have to type in all of that. So negative 1 plus I square root 3. Then cube it. Oops, I forgot to come out before I... Let me delete that. See how I forgot to move out of the house before I put the parenthesis? Okay, so see how now I've plugged that in for x, where the 2 was, now I have that. Now I cube it, and I minus 8 from it, and I get 0. So that confirms that that is the second solution. And now, of course, to check this one, all I need to do is copy and paste this one and go back and change what? Right. Instead of plus I, it's minus. And I get 0. So that means I did it right because all three of these worked and made it equal 0 when plugged in the equation. Okay, let's try another one. Go to the next page. Okay, the next page, it kind of gets cut off, so I'm going to rewrite the original polynomial over here so you can read it. X cubed plus 4x squared plus 4x plus 3 equals 0. So what do I need to do first? Graph it. So y equals x cubed plus 4x squared plus 4x plus 3. Okay, now remember, this is a degree 3 polynomial because its highest exponent is 3. So that lets me know there's going to be 3 zeros. However, when I graph it, I can only see one of the 3. And where is that one? Negative 3. So that lets me know right away one of my 3 solutions is at negative 3. I'm going to use that 0 for synthetic division. What numbers come here from the polynomial? Right. Now I do synthetic division by bringing down the 1. It multiplies by the negative 3 to make a negative 3. Those combined make a 1. It multiplies by the negative 3 to make another negative 3. When you combine those, you get a 1. And when you multiply that by negative 3, you get a negative 3, which gives you a remainder of 0. So now that I have divided the original polynomial by its one real 0, I get x squared plus 1x plus 1. I'm now going to solve that using the quadratic formula. The first thing I need to do when using the quadratic formula is what?
Find the A, B.
Right. Identify the A, B, and C. What's the A? B, and C. Okay, all of them are 1s. Now I plug them into the quadratic formula, so it'll be x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. Every single letter gets a 1 plugged into it. Now I start simplifying. I'm going to bring the work up here just so I have room. It ends up being x equals negative 1 plus or minus the square root of what? Negative 3 all over 2. But is the 3 one of those you can factor tree like we did the 12? No, because 3 is a prime number. So for the final answer, it'll be negative 1 over 2 plus or minus I square root of 3 over 2. because you can't actually simplify that square root of 3, so it stays in the house, but the negative becomes an I. And so down here you would write your answers as negative 1/2 plus or minus, or actually plus, hold on one second, plus I root 3 over 2, and then your other one is negative 1/2 minus I root 3 over 2. Now those are kind of uglier than the ones we did before, so I'm not going to take the time to plug those in, but you could. You would just have to use N over D. Okay, why don't you go ahead and get started on the next one by yourself and see how far you can get it. Negative 2x cubed plus 6x squared minus 29x plus 50. Okay, it's degree 3, so I know there's going to be 3 solutions, but when I graph it, I only see it hit the x-axis one time, and that one time is at positive 2. So I already know positive 2 is one of my 3 solutions. I'm going to use that one solution to find the other 2 that are imaginary. What numbers do I bring down for synthetic division? No, that's if you're writing it as a factor. Like if you were writing it, it then multiplies by 2 to make negative 4. That combines to make a, that multiplies by 2 to make a, what's negative 29 plus 4? And multiply by 2 makes a negative 50. So, when we do that, we end up with negative 2x squared plus 2x minus 25. Now we need to solve that by quadratic formula. So we have to identify the A, B, and C. What is the A? What's the B? And what's the C? Okay, so it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now I just start simplifying. I'm going to bring the work up here. X equals negative 2 plus or minus the square root of, what is all of that in there? Negative 196 all over what? Negative 4. Now, 196 can be simplified. However, before you start factoring it, I would go ahead and check in your calculator to make sure it's not a perfect square, because that would save you a lot of time. And it is. 196 is a perfect square. The square root of it is 14. So, this now becomes negative 2 plus or minus 14i, correct? And then I'm going to put that negative 4 under each part so that I can reduce each one individually. What does that reduce to? Positive 1/2. What does 14 over 4 reduce to? But right, 7 over 2i, and you don't have to worry about that. It will be accounted for with the signs. So our first solution is 1/2 plus 7 over 2i, and our second one is 1/2 minus 7 over 2i, for a total of 3 solutions.